You now know Ski, and so let's write a larger program together that draws Sierpinski's triangle. So I haven't told you about drawing yet, but we include in the project that we're going to build something called Turtle Graphics, which lets you draw on the screen using commands such as move forward and turn left. Okay, so how do we draw Sierpinski's triangle? Well, what is it? You'll see when it starts to draw. Sierpinski's triangle is made up of 3 Sierpinski triangles. Except for, there's a base case where Sierpinski's triangle is just a regular triangle. So let's write code that does that. The first thing we're going to do is create a higher order procedure called repeat, which just repeats the function fn k times. So if k is 1, then we'll just call the function. Otherwise, we're going to use this special form begin, which just says do multiple things. So we'll call the function, and then we'll repeat the function k minus 1 times. Okay. We'll triangulate a function, which means to repeat the function exactly 3 times, and each time you follow it by a 120-degree turn to the left. So that's what LT120 means, is that turns left 120 degrees. So if I repeated drawing a line try times, that would mean draw a line, turn left 120 degrees, draw another line, turn left again, draw another line, and that would form a triangle. Okay, so repeat 3 of a procedure which takes no arguments, and first calls the function here that was passed in, and then turns left. So Sierpinski's triangle is just to draw Sierpinski's triangle 3 times. Okay, so we'll say draw 3 legs of Sierpinski's triangle, which tries, which tries a procedure which takes no arguments, and if k is 1, k is the depth. Which, if k is 1, just moves forward, some length d. So it just draws a line, because the base case is Sierpinski's triangle is just a regular triangle. Otherwise, it draws a leg of Sierpinski's triangle to the specified depth k. So what does it mean to draw one leg of Sierpinski's triangle? Well, you draw Sierpinski's triangle, but half the size of what you'd normally draw, and to a depth that's 1 less than what you had before. Then, you pick up your pen, and you move to a new location, and then put your pen back down. So picking your pen up and picking your pen down means that we won't leave a line behind. Now let's see what happens when we run this code. So I'm going to run our scheme interpreter, executing everything that's in this file, which means that it executed repeat to define what repeat means, and tried to find what try meant, and then we knew how to make a Sierpinski triangle, and finally, with a line length of 400, we drew a Sierpinski triangle of depth 6. And there it goes. So what's happening at each moment is that it's drawing a leg of a Sierpinski triangle. When it hits the base case, that's just a regular triangle. And then the Sierpinski triangle itself is a 3-piece triangle. This one is made up of 3 of those. And then the whole thing is made up of 3 of those. We finished drawing the first one, and we're in the middle of drawing the second one right now. All of this happens just with this amount of code, where the built-in procedures we're using are move forward. Here we move forward while we're drawing, here we move forward while we're not drawing. And then we take a left turn every once in a while. And when we want to not draw, which is going to happen in a minute, so we're going to move way up here in order to finish the triangle, we'll pick up the pen first and then put it back down in order to start drawing the base cases yet again.